Okay, so this is question 4 of 2016 paper 2. As always, I suggest you pause the video and have a go at each part before we link in with it. So I'll assume you're back. Now, question 4 case part A. The line L contains the points A, so that's just the label of the point, so the point 4, 5, and a point B, which is 2, 0. Okay, find the equation of L. Now, if you have a linear equation, okay, so let's just quickly run over some of this stuff here. That's your x-axis, that's your y-axis. One thing about a linear equation is that x and y have a relationship, and they'll change in proportion. Okay, so as x increases, so does y. Now, if you could have a line going down a negative slope. As x increases, y decreases. But there's a direct relationship between the two things, and that's what the equation of the line describes. Now, you may or may not get that to its fullest, but that's ultimately what's going on. Now, if you have 2 points on a line, you can draw it. No, I probably should have actually drawn this line. So if I could get rid of this thing here for a second, this line, let's actually do that. No harm, gives yourselves a basis to understand this. So 4 on the x, 5 on the y, ballparking, like literally ballparking this here. Just getting the trend. So that's a 2, 0, 2 on the x, 0 on the y, somewhere around there. So your line goes through those points, and okay, roughly. Okay, so what I know first for looking at that, okay, it's a pretty steep line, positive slope, be a pretty large number, okay, and let's get stuck in and do it. So to do this, okay, I need 2 things. Okay, I need to find the equation of a line. I need 1 point on the line. Now I have 2. The reason I'm being given 2 is I also need the slope of that line. Okay, and they're looking for me to find the slope of that line using the slope formula. So let's go and do it. It's the slope formula first here. Again, this is given to you on the maths tables. There's no harm in pointing out where that is. So go back a step here. Here's your coordinate geometry formula. That's the ones, yeah, you can't think of anyone you'd need. No, where's slope? Oh, sorry, okay, I can cover it all. So your slope formula on top here, okay? Now, generally, people learn these things off. You don't have to memorize it, but you just have to know where to look for it, okay? So first step, once you see slope, go write the slope formula down, okay? So that alone will get you marks, okay? I then go, I'm being very piecemeal here. I'm identifying my 2 points. I'm labeling them. First x value, first y value, second x value, second y value. Now, it doesn't matter if you swap them around and call the 0.20 x1, y1. Ultimately, you get the same answer. Put my values in place. So instead of y2, I'm putting 0. So I have that done. Instead of y1, I'm putting 5. So I have that done. x2 is 2. So that's done. And x1 is 4. So that's done. Now, they're all positive numbers, so they can go in without brackets. You could use brackets, but you just add an extra layer of work. So when I multiply the minus by the number, it won't change sign. Minus by plus is minus. Now, if that had been a minus 5, you need to be more careful, and that's where mistakes are commonly made. It'd be minus by minus 5, which would make it plus. But that's not the case here. So I'm putting my numbers in, no penalty, no brackets. So I'm doing the subtraction now. 0 take away 5, okay, is negative 5. 2 take away 4 is negative 2. Now, if you're not comfortable, you could program the whole thing in the calculator and let the calculator do the work for you and worry about the rules of power or rules of signs and multiplication. But ultimately, I'm getting an answer of minus 5 over minus 2 now. Here, the minus divided by minus applies. So my answer is a positive 5 over 2, which is basically the same thing as 2.5. Okay, and I could say 2.5, I could say 2.5. It doesn't really matter, but I'm going to leave it as a top-heavy fraction. So I have my slope, okay, so I have my equation of line formula. Again, it's in the maths tables, so I need to know a point. Now I've picked 4, 5. Could have picked 2, 0. Wouldn't matter, I'll get the exact same answer. I picked 4, 5 for, I can't remember what the reason was. I've just found my slope, okay. So I put my numbers in, so instead of the y1, I'm putting the 5. Instead of the slope, I'm putting the 5 over 2. Instead of the x1, I'm putting the 4, the value of 4. Again, they're all positive, so no penalty. I have put them in the brackets, I suppose, just because that's what I did. It wouldn't have mattered. It's going to end up being y minus 5 equals 5 over 2 times x minus 4. So the brackets will be moved without penalty. Now what I've done here is, again, this is I suppose a trick that we'd use for speeding this up. I've multiplied the 2 this direction, I've multiplied the 5 this direction. Now, what I could have done alternatively is I could have multiplied across by 2 to cancel the 2 on the bottom. And that's a perfectly valid strategy. It just, that's what, this will always work, and it's using the fact that I multiplied across by 2, but just not having to do that step. But if I do that, 2 times y is 2y, 2 times minus 5 is minus 10. Now the 5 goes this direction, 5 times x is 5x, 5 times minus 4 is minus 20. Now they say in the question they want this in the form of ax plus by plus c, where basically a is positive. So they want it all on one side with a positive, so the x positive. So to do that, I'll bring the minus 10 across to the right, and I'll bring the 2y across to the right. And that leaves nothing on the left-hand side. 5x doesn't change, and nothing being added to it. Minus the plus 2y becomes minus coming across the equal. The minus 10 becomes plus 10 coming across the equal, which when it combines with the minus 20 plus 10 equals minus 10. Now you could argue, well, that's not in the form they wanted. Didn't they want 5x minus 2y minus 10 equals 0? But that is what I'm saying. It's just not, it doesn't look precisely the way you might think it should look, but it's perfectly valid. Now, just the last part of the question, I haven't actually dealt with this, but all that's saying there is that a, b, and c are elements of z, means they're integers, so they could be positive or whole number, positive whole numbers. Sorry, positive or negative whole numbers. Right, brain freeze. Okay, so that's part A. Now part B, okay, they're looking for me to just draw the line. This is dead handy, okay? I suppose once you know what you're doing. But ultimately what I'm using here is this fact that's really, really, really important in coordinate geometry. And that's the fact that all along the y-axis, the value of x is 0. That's the coordinate 0, 4, 0, 3, 0, 2, 0, 1. Now, alternatively, or equally valid, all along the x-axis, the value of y is 0. So 9, 0, 8, 0, etc., etc. And that fact has been used many, many times to solve things in coordinate geometry. And this is one scenario where that's very important. So this line, no matter how you cut it, like I'm being facetious here, it will cut both the x and y axis. The only way it wouldn't is if it was parallel. Now the equation line, if you hit a line here, now we're assuming this is straight, that's the line y equals 3. You see there's no x value, because okay. Now the line here, it's supposed to be straight. That's the line x equals 3. You'll notice there's no y value. So every equation that has an x and a y value is I suppose, not vertical or horizontal. It might be very steep, might be very shallow, but I'm going to say this one here, it's going to be a line that crosses the x-axis and the y-axis. Now, I don't know if that's actually what this line looks like. We'll find out in a second. Okay, but it will definitely cross the x-axis and will definitely cross the y-axis at some stage. Now, at the x-axis, the y value is 0. So if you look at the equation up here, at that point, this thing is gone. So that's x is equal to 8 now. Okay, my point should be over here. Alternatively, and if I got rid of that, just whatever. Okay, the same thing. Bear with me 1 second. Along the y-axis, the value of x is 0. It's gone. So 2y equals 8. Now, 2 times some number is 8. That number must be 4. Okay, so that's the point 0 on the x, 4 on the y, which would be here. Okay. Okay, so actually my line's completely arseless. If I got rid of it real quick, it should be a line that comes down through there and through here. Okay. Now, excuse my crudeness, but I have the answer done on the next page neatly, so I'll run through that again. That's my my line. I'm stating here at the x-axis y is 0, so I'm replacing y by 0. It goes away. You got your x is equal to 8. That's the coordinate 8, 0, which I've done there. At the y-axis, x is 0, so just like before, 2y equals 8. Therefore, y is equal to 4, and that's the coordinate 0 on the x, 4 on the y. Once you have 2 points, you can draw a line. Okay, make sure you use a ruler. and job is done. Love that question. Okay, comes up fairly regularly. Now, this is I won't use any bad language, but this is a nasty enough question. Mainly because there's so many ways of doing it. Okay, so I'm going to try to cover all three, but we'll just see which one suits you. Again, I would strongly suggest pausing this right now, give it your best shot. If you're unsuccessful, fair enough. If you're successful, fantastic. Okay, but at least you'll have a chance of trying to do the problem solving yourself, and that ultimately in maths, what to do is as important as how you do it. So having a strategy is the most important thing. So anyway, so use a graphic, numeric, or algebraic method to find the coordinates of L intersection K. Okay, now you found L a minute ago. They've just given you K, you've just drawn K, so L is somewhere on this graph. Now you could basically graph L. Okay, you have your equation for L there, 5x minus 2y minus 10. Using the exact same principle as we've done here, draw that, okay, and see where they intersect. Okay, that's the graphical method. So I'm showing that here, graphical, okay, and you'll find your point where the two lines cross is 3, 2.5, okay, perfectly valid. Or you could use the numerical method, okay, so you have your equation of the line, and you're saying that halfway along that line, okay, halfway between the points 2 and 4, okay, is 3, okay, and okay, so this wouldn't be my preferred method, and just right now I'm having trouble to figure it out, but what I'm basically doing is I'm taking the original 2 points on L and getting the halfway point between them, I suppose the midpoint, which is 3, putting it into my equation that I found for L, and getting the y value. And it just works out that it's 3 and 2.5. Now, to be honest, I would never think of doing it that way. I would either graph it, or to be honest, what would have occurred to me straight away would be simultaneous equations. And simultaneous equations is a method where you can find two unknowns in an equation where you couldn't normally solve it by comparing it to a second equation. And I'm sure in other videos you came across me dealing with this, but this actual method we're going to use here is the elimination method. Okay, so I'm looking here at my two equations, okay, and I'm going at just by pure chance the way it happens, the y's are already negative, opposite sign of the same magnitude, so they'll cancel. 2y take away 2y is 0. I'm going to combine the two equations, okay. Now normally I'd have to create that situation, multiply one on both equations by a certain number to make one of the variables equal in size, but opposite in sign. So it's happened here just the way it works out. So that's gone. So 5x plus x is 6x, minus 10 minus 8 is minus 18. Now that's an equation of one unknown. It can be solved. So let's do it. Bring the 18 across. So the negative 18 becomes positive going across the far side. 6 times some number equals 18. That number must be 3. Now I'm going to use that number. I've now found one of the two variables. So these are no longer equations of one unknown, as I know what, in this case, what x is. Now I've taken the easier one, the second equation, probably because it's got a lower value of x, and I'm lazy. But I've written out the equation, and I've put 3 instead of the x. Now the y is still unknown. I'm going to go ahead now and solve it. So first thing I can do is add the 3 and the minus 8. Now what I've done here is I've done that and got minus 5, and then brought the minus 5 across the equal, and it's turned into a positive 5. Okay, it was subtracted on the left, goes across, becomes added on the right. So 2y equals 5. Okay. Now, what number when multiplied by 2 gives you 5? Gives you 5. Okay. That number is going to be 1.5. Sorry, 2.5. 2 times 2.5 is 5. Now I've done that by bringing the 2 across. I can find what the actual number is. So the 2 I'm bringing across was being multiplied on the left, comes across, becomes subtracted. So divided. And I end up with y is 5 over 2, which is the same thing as 2.5. So my coordinate there is 3, 5 over 2, or 3, 2.5, whichever way you want to express it. And that's the algebraic method. Okay, so using algebra. So again, graphical might be the most obvious. Okay, numerical, I wouldn't think of doing that. Algebraic would be the one I probably personally would default to, mainly because I know that method inside out. And it's one of these methods you kind of have to know inside out. So when it happens, you're kind of almost glad it happened because you're in safe territory. Okay, so I'll move on to Okay, there is no D. Okay, so thanks very much. Probably this video is a bit longer than normal, and thanks very much.